Hello everyone! Welcome to the Singapore Geospatial Festival 2021, which is an event that brings the international geospatial community together for co-located activities, promoting the use of location-based and mapping innovation. This event is organized by GeoWorks, which is Singapore's Land Authority's Geospatial Industry Centre. Today, I'm excited to introduce the GeoMarketplace event, where our geospatial startups and scale-ups, also known as GeoTechs, will be sharing more about their products and solutions. You'll be having 4 GeoTech companies share today at the marketplace. First, we have Lineable, followed by Envision, Urbanetic, and then UNL. If you have any questions during the webinar, please feel free to leave them in the Q&A chat box, and we will answer them at the end of the webinar. So without further ado, I will now pass the presentation to Tyler from Lineable. Over to you, Tyler.
Okay. Good day, everyone. I'm Tyler Moon, CEO of Lineable. Today, I'd like to share the story that how we are innovating traditional old technology and creating a network for vulnerable. Firstly, I need to talk about survey markers. What is a survey marker? It's one of the crucial infrastructures for almost all countries. They are control points to prevent property conflict, but are easily removed, damaged, and difficult to locate. Even though there has been these problems, it never improved for a few decades. Survey markers are still metal plates. The land surveying system is mandatory to precisely measure the area and help to avoid conflict between the owner of the property. Therefore, there are a lot of survey markers, also called survey control points, that are used as reference points in almost all countries. And the whole system is usually maintained by the government. As I told you on the previous page, survey marker is hard to manage. Survey marker is easily removed, damaged, and difficult to locate. You can see this metal plate. It's one of the survey markers, and other survey markers are also very similar to this. So, because the traditional survey marker is just metal plate, it is often removed or damaged by construction or car or something like that. But it's almost impossible to be aware of those immediately when it is removed or damaged. So government should spend a lot of additional labor cost to investigate all survey markers. Besides, surveyors sometimes couldn't find the survey marker because it's pretty hard to find it only by eye check. So we developed a linear marker. I can proudly introduce a linear marker. We renovated the traditional survey marker totally. Linear marker is the IoT version to replace these physical dummy markers. So it is easier for the manager to automatically manage these markers on the online platform. All linear markers will be available online via LTE-M network. Finally, it's possible that any government agency can manage their survey markers automatically and remotely. A linear marker was designed with many surveyors' voices and can provide the function according to surveyors' needs. It can detect shock and movement via 6x accelerometer in real time, so the manager can notice an accident immediately and replace or fix it. And as I told you before, surveyors sometimes couldn't find the survey marker because it's pretty hard to find it only by eye check. For solving this problem, we use ultra-wideband technology. Linear marker is embedding ultra-wideband technology and can connect with a smartphone via ultra-wideband. It means surveyors can find any linear marker with very precise direction and distance information generated by their smartphone. And linear marker is installed on the ground, so we made it very durable to endure harsh conditions like cold weather and very heavy pressure. Linear marker is not just hardware. It consists of the hardware and the management system. So through our management system, governments can manage all survey markers without too many human resources. Managers can see also linear marker status, such as battery level, shock or movement detection, tilting status, and something like that at once. Also can get instant alert when abnormalities are detected. I'd like to emphasize that we are not on the concept stage now. We signed a contract with edX, the Korean government agency, who is managing over 1 million survey markers in Korea. Recently, we finished the final test with edX, and now we are preparing to install it in 3 cities in Korea. Thus, we can introduce our linear marker as an already proved and practical solution. Linear markers are also useful as a geolocation infrastructure, as all linear markers are installed at a regular distance from each other, like 200 meters, and each one has its own fixed location coordinates. They can create their own network by emitting a unique signal that other devices can detect. The data transferred from this signal will be sent and analyzed to be compared from the server side so that the mobile device can get the precise location without using GPS. We talked with several micro-mobility companies as their battery has a limited capacity, depending on only GPS cause a lot of battery consumption. So we expect that linear marker will contribute to their system as another geolocation infrastructure. I hope you don't forget the title of this presentation, Renovating Traditional Old Technology and Creating a Network for Vulnerable. We started linear marker for our mission. Our mission is to make all children safe. Linear markers will provide a network for emergency situation. If linear markers detect a predefined danger signal from any other devices via short-range communication, such as Bluetooth or ultra-wideband, linear markers are activated to send those signals to their server through LTE-M network. So we can recognize someone's emergency situation in real time. It means we can prevent the vulnerable from being missing, pets, elderly people, and especially children. Now we are ready to provide our solution to any partners for our mission, not profit. So please don't hesitate to contact us. With Lineable, you can get the solution to manage your infrastructure and contribute to our children. Thank you.
Thanks, Tyler, for our presentation. So next up, we have Envision to share more about their products and solutions. Over to you, Esther.
Okay. Okay, thank you everyone for having me here today. I'm Esther from Envision, and today I'll be sharing with you how Envision optimize the third-party logistic process efficiently, as well as to utilize resources with data intelligence. So let me start by sharing with you a bit about Envision. So Envision is a data technology company in Singapore that aims to help organizations optimize resources with AI, data intelligence, and geospatial technology. And with the data technology, we help companies match data and move goods in the supply chain logistics, as well as the maritime ship supply industry, where we saw potential to tap on digitalization to optimize their resources and operation. So today I'll be sharing with you our journey and our experience where we develop and deploy our supply chain logistics solution with third-party logistic company in Singapore, starting with understanding our clients' challenges and requirements. So firstly, in the supply chain industry, there are a lot of manual processes, and there's a challenge of processing documents such as the delivery order. So we know that a delivery order can come in different file formats such as PDF or even Excel file format, and they have their own layout, as we know that each customer will have their own layout and not conform to a standardized format. So the staff would then have to manually identify key information such as your delivery details, item details, and in certain situations, standardize or even geocode the delivery address to enter the information to the enterprise system. So this enterprise system could include your order management system, warehouse management system, or even your transport management system. And the manual processing of geocoding and manual entry makes it really time-consuming and labor-intensive, as well as prone to data error, which may affect the operation process throughout the end-to-end supply chain process. Secondly, we also identified that transport planning and route planning are traditionally done manually, which really relies on your transport controller presence and experience to optimize the job assignment as well as planning. And furthermore, when it comes to route planning, it will be based or heavily reliant on your location data obtained from the address. So this human-dependent process really puts the business operation at a vulnerable position where the productivity and efficiency are closely tied to the availability of the staff, as well as the human ability to kind of respond accurately and quickly to the delivery order. Thirdly, similar to any organization, our client actually uses different operating systems to get their information from different sources. So in the supply chain logistics cycle, it's characterized by several independent process and activities. So this includes your order processing, transportation, your warehousing. However, we realize that such activities are usually controlled and managed by separate enterprise systems to address the different business needs. And this can lead to a data silo or information silo. And it's very important for systems to communicate to one another to ensure that there's data visibility, accessibility, and connectivity. So with a more in-depth understanding of our client's challenge, here is how we use our data intelligence to address these challenges that we have identified. Firstly, automatic processing of automation with IPA, Intelligent Process Automation. It's a software that combines robotic process automation and AI to allow us to automate high volume of repeated tasks. In this case, it's your incoming delivery order, as well as adapt to the different data that is being exposed to, because we understand that how one format a delivery order differs accordingly from one customer to another. So in this case, we look at automating the process of document with IPA. So the key feature of IPA includes 3 points. Firstly is our ability to automate data standardization. So a very simple example in terms of how one might write a date, some might write the year, the month, or the day first in terms of how they write the sequence. So we are able to standardize the date information to ensure that, hey, every different incoming delivery order, we are able to extract the information and standardize the information for the logistic provider. A second feature would be our ability to intelligently extract key information from a delivery document. So from a delivery document, we are able to extract, let's say, the transport delivery information, the item information, and the dimension details. And the third point would be a multi-level matching, where we can actually match the unit of measure in terms of your item. So with data technology, it really reduces the need for manual intervention, and it allows our third-party logistic provider to kind of respond regardless of the time of the day, where especially we understand our customer operates in different time zones. Secondly, to address the dependency of human planning, Envision uses machine learning and decision optimization algorithm to plan and schedule the transport job to meet the requested time window, and we are able to consider multiple constraints for the assignment and planning. So some constraints will include your vehicle capacity. So depending on your vehicle capacity as well as your item dimensions, how can we optimize the item to fit in a vehicle? Other constraints we look at is your driver performance, your cargo type, whether it's a fresh food, cold chain food that requires a refrigerated truck. So this would consider as temperature requirements and urgent order. So our optimization algorithm also optimizes the route by using location data with geocoding, so that we can locate the location of where we want to optimize in terms of the job assignment. And lastly, Envision has an integrated platform to facilitate the data usage across various departments or various systems. This is to ensure that there's a smooth data exchange across your enterprise process by integrating the different enterprise system to a central data platform, whereby we can facilitate the exchange of information. So you can think of it more like a handshake. We can put the various enterprise systems together. This also allows our customer the flexibility to change and plug in different enterprise systems, and they do not have to replace a system just to ensure that they are communicating to one another. So our Data Central platform really looks at integrating the various information from various enterprise systems to a centralized platform to ensure that information are being streamlined, standardized, and visible throughout the end-to-end process. Now, I would like to play a short video of our delivery visibility and job planning optimization. So let me see.
In the logistics operation, incoming delivery order is received via email or third-party platform. Envision's smart logistics solution is able to extract information in the DO from various sources with document processing automation and send the information to other enterprise systems. In Envision TMS Logistics Central Portal, the Manage Request pages shows the transport request that is automatically generated from the order management system with Envision Central Data Platform. Key information such as the equipment requirement and time constraint is also captured for optimization. Users can run the job assignment optimization on the planning page. With the total transport request for the delivery date, delivery time constraint,
Seems like there is some connection issue. I'll just go ahead and skip ahead.
constraints, equipment requirement, resources availability such as the available driver, vehicles as well as vehicle capacity and other addition constraints. Envision Optimization Engine optimize the job assignment automatically. The optimization goal is to minimize the total distance traveled by all vehicles and the spread of jobs for each individual vehicle. After the job assignment has been optimized, the user has to confirm the job for delivery at the job confirmation page. By selecting the plans based on vehicle, the user can also assign individual jobs. Information such as the vehicle job number, schedule time, volume is available to help the user make an informed decision. Once completed, user can confirm the plan for delivery by pressing Confirm. Confirmed jobs can be viewed on the job sheet page, which allows the user to track the jobs with the trip number and sequence of each vehicle. Envision Intelligent TMS Portal is coupled with a driver app that provides real-time delivery tracking to the controller. The carrier app shows the pending, active, delivered, and undelivered jobs for the driver. User starts the day by accepting the pending job, and jobs that are urgent will be highlighted. For active jobs, users are able to navigate jobs with Google Map, capture signature, and capture POD. Upon completed transport job, driver marks the completed transport job as delivered, and the driver is able to preview the signature and POD. And for jobs that are undelivered, the driver has to input the reason for operation tracking. Controller is able to track the driver based on his current job and view the signature and POD captures on the portal. Envision Intelligent Transport Management System reduce delivery logistics cost, maximize resource utilization, improve business bottom line, and finally leading to a greener and smarter city.
Okay. Okay. So the video really shows how Envision kind of have our optimization algorithm to optimize the job assignment and also ensure that visibility is provided to both controllers and drivers. So that's just a quick introduction or a sharing of our solution. Now, I guess the takeaway here is that really with data technology, the goal for us is to help organizations move forward with digital transformation. And this is through providing connectivity, visibility, and accessibility to the stakeholders involved throughout the operation process. And the data technology really promotes an efficient logistic ecosystem, which optimize the resources and reduce our logistic costs when we tap on the data technology. And ultimately, our goal is to fulfill the 8 rights of logistics, which is to get to the right product for the right price, with the right quantity, to the right customer, to the right place, at the right time, in the right condition, and lastly, at the right cost. So with that, I've come to the end of my sharing. Again, thank you for having me. I'm happy to connect. Thank you.
Thank you, Esther, for Envision sharing. So next up, we have Sebel from Urbanetics to share. Over to you, Sebel.
Thank you. Okay, thank you very much. Let me share my presentation. Okay. Here. All right. Hello, everybody. My name is Saibal, and I am the co-founder of Urbanetic, which is a web-based software platform to help realize smart city vision and objectives of the world cities. So we are not a smart city application or smart city product company, but we provide the platform, which you can see on the right-hand side, primarily a unified data model, some of the apps, and so that their life cycle, you could manage, plan and manage the city across the life cycle. Now, this is basically the solution is. So it's essentially a SaaS platform. And the idea is to rapidly parametrically model digital twin of cities in 3D. So we are building libraries of cities across Asia at the moment, and of course we have few in like the part of London, part of Norway, and also in Birmingham. So these are when it gets in libraries, so anybody who has a subscription could actually build a 3D model of the city for themselves and run some analysis. They can explore, analyze, and visualize cities in 3D. The idea about this product is to bring the whole city in one place. So unification of the data, attribution and unification. And when you say unification, so when you get all the data unified, you can build a city like that, which is at the moment LOD1. But however, it allows you to run a lot of simulation. So you could change the left-hand side. These are the parameters, and the right-hand side is your dashboard. So this will be also depending upon who is subscribing. So different stakeholders have different issues to resolve, and hence a different, not the view, but actually a different dashboard they will get. So say, for example, a contractor will be different, or a master planner will be different, or an investor or a fundraiser for development will be different. How we build the solution is very simple. Well, it's not that simple, but in a way, in a diagram, is simple that we need to get all this data. So these data is actually put together, comes from municipality and other agencies. Some we use open data, satellites, IoT, and put in all together. And with all the attributes, so we have a semi-automatic data correction module, which actually transfer what we eventually want to build is a unified data model of the city. Once it is unified and attributes are in place, you could then basically run these applications. The application, it's a number of applications. It could do urban renewal. It could be land use planning, infrastructure capacity. It could be ESG monitoring, asset planning and optimization. So it's a number of range of application can be developed either by the third party over the API, and they can visualize it here with our own rendering engine. Or it could be our own, what you call is a native application, which is sustainability capacity as well as development feasibility. These are some of these projects that we have done. We started off with Melbourne in 2015, and then went to Birmingham. We had this is in Norway, a couple of cities in Malaysia, actually 3 cities in Malaysia, and also in Phnom Penh. And this was together with Surbana Jurong and Singbridge and Sendas. We had this whole city in India that was actually Singapore government's project. So let me go through what are the stuff that we do. Actually, main thing that what customers normally are using our solution is as a digital master planning tool. That means having a master plan as a live document. So it's all digital. You update digitally, you review digitally, you manage it digitally. That is a major change in most of the countries, except probably Singapore, and so that where people are still using either manual process or it's a desktop application they will be using. The other is Township Management Reimagined. This was one project in Vietnam where we actually took a concept master plan design in AutoCAD. We could actually import it and parameterize it, and then you run analysis, traffic or flooding and other stuff that you could do. So that's another application that we can use from our platform. The next is again the site planning. This is Cambodia, where a small island, which is 1.5 square kilometer, we're basically taking a plot of land and actually doing a development feasibility analysis. And you can see the typologies, you can see the land use planning in based on the land itself. So Fabric is basically used to simplify the planning and development through digitization of data. So using some machine intelligence to learn on the feasibility modeling as well as integrated data model. Then the next is also looking at the IoT. As you say, that we are basically, as the IoT part of the platform can take. This example is actually asset management of towers. And you know there are 3.5 million telecom towers in the world, the base stations. And these are to be managed as an asset. So we are able to basically take the data and actually ingest them and then integrate them with the city's digital twin itself, so that people who are managing the asset could see their asset. It could be basically a tower, click on it and do the maintenance and other stuff that you could do using it as a tool to manage the assets and also monitor the asset's performance. So the other application, this was recently done in Penang. You can see this is where we are actually, this is a tool where we could use visualization of building codes and regulatory stuff. So you could see that this building, it can be easily approved because it is within the basically building code. So we basically visualize the building code in a translucent kind of a box. And then we will see that how, so as you can still see that it still has some height that it can go in, and then you can do a development feasibility modeling here. This is very quick. You just click on any plot of land and then it will automatically tell you what can be done with that plot of land. You can click on a building, demolish it and redo. So those kind of stuff can be done. This is the land planning, land use planning in again Penang. And most importantly, using IoT and some other data, you are actually able to predict, and this is a prediction module rather than actual. So you can actually take the actual data through IoT, but can we use the prediction model to see vulnerability, overall vulnerability, fire hazards. This is Georgetown, and as well as what you call is a surface temperature that we are basically modeling here to see that which are the areas. So you actually here the application to know how many trees to be planted in what part of the city to bring down the heat island impact and the surface temperature low. So these are typically basically, so as I said, multiple applications can be done. And I would like to probably introduce a short video of one of the applications that we have done early on in what you call in Melbourne. I have actually, sorry about that, forgot to. So there you go. So this is basically a Lorimer precinct. It is in the part of the Fisherman's Bend in Melbourne. What you do is you can create a project, go right in Lorimer, then you create a new project. Once you create a project, you launch the project, you see the site here in the map, and then you could actually, what you call is a cadastre. You can either subdivide, amalgamate, as you saw in our, we can make our cadastre on the map itself, or in this particular case, we have done it before and we are loading the cadastre, which is a chain cadastre, and we are trying to say if this is the new cadastre, what are the impact, which is social, economic, and environmental impact. So you're using your what you call is procedural modeling tool that we are able to do multiple modeling based on this planning scheme of the city, as well as building codes. So it basically reads the planning scheme, the building codes, and then say that this is how, given these regulatory measures, this is basically how a developer can would do a feasibility analysis of a development, or in other words, for a municipality, this was done for a municipality to see whether with the building codes and the regulation they have, can they attract a developer to come in, whether they see a money or not. We have not done this here. It actually integrates with a cash flow at the back end, and basically using a 10 years terminal value just to do the GDV analysis. You can see the later on the measures. It looks at the basically land costs, and it looks at the rental income from the commercial side, and then it basically looks at the input, which is the market demand and supply, and generally it gives you an idea whether for a municipality whether a developer finds it attractive or not, given the regulation that they have basically put has published. So you can see here the planning schemes in detail, which is also a development side, which is a land use mix. You can do that, whether it is residential or it is commercial or retail. So this is typically, as you see, that's how you can calculate the GFA, number of occupants, jobs. These are actually can be parameterized. In this particular, it has been parameterized and fixed for Melbourne itself or Australian government. So the data came from the Victorian state government, which gives you more strategic data, and the Melbourne Council, which gives you more what do you call spatial data to basically model the viability, feasibility, and environmental impact within a development in a city. So I like to. This is basically, you can go on. You have already got the idea how the whole thing works. If you have any question later on, I would be able to answer all your questions. So with that, I like to end my presentation today, and look forward to connect with you and also hear some of your comments. If you have, let me see. All right.
Thank you, Isabel. So next up, for the final presentation, we have Pascal from UNL.
What do I did? I did some mistake. Okay, wait a moment. Okay, I need to get out of here. Just give me a second. Is it creating some problem? I am not very sure. Okay, good.
No.
All right, good.
Please stop your presentation.
Okay.
So
okay, Pascal, you can go ahead to share now.
Okay, if I'm out, I will. Okay, good.
Okay, everyone. Thanks for listening in and letting us participate in this event. I'm Pascal, one of the founders and Chief Product Officer of UNL. UNL, Universal Named Locations, where a company started in 2018 in Amsterdam, but moved our headquarters to Singapore 2 years ago after also having investments from SgInnovate and collaborating with GeoWorks, of course. Company of about 15 people, big, with offices now, like I said, in Amsterdam, Singapore, and now recently also in Delhi. But more interesting, what do we actually do with UNL? What we try to create is a smart location platform that provides mapping and data tools to create your own location-based services. Essentially, what we did is actually build a 3D grid of microcells on top of the Earth physical service to give every location on Earth a unique identity, a unique identifier. Identifier we actually see not just as a way to indicate the location of an object or a building, but actually also as a way of communicating with that location, of a way of interacting it, in a way to store data on a location or add programmability. So essentially, what we see is we've built a 3D infrastructure like you would see in a Minecraft to interact with locations. And that's the core of UNL and how we are building our location-based infrastructure from the ground up. So why cells? Of course, cells are an interesting way to indicate a location, but so are coordinates, and you can do a lot with the coordinate system and then geofencing. But if you look from a purely programmability perspective, coordinates geofencing is still a very complex and inefficient system. And what we do is use a cell structure for all our services. It's been done partially for mathematical analytics already before. You see with Uber, they use H3 hexagons, Google has Google+. But we see our 3D grid as a foundation for all our location services. So what we did is we created a structure with multiple sizes of cells for different use cases. So they can be as small as 1 square centimeter. That could be for buildings or for drone navigation, etc. But the cells can also be as big as squared kilometers, as the sizes of countries, and they're all connected. So it's sort of a parent-child relationship, where the bigger cells, they know which smaller cells are within them, and the smaller cells know which bigger cells they're part of, and they're all connected, and they all communicate continuously. And more importantly, also, we've added elevation to this, as we see height as a super important factor. We have two elevation variables. One is, of course, exact elevation in centimeters, which is good for drones, navigation, airplanes, etc. But we also have a floor height for buildings, where you don't know the exact height, but still want to indicate on which level you are. But the key is that by using this cell structure for everything that we do, we sort of create uniformity in all our geospatial data, which makes it much easier to store data, to search for data, and to reuse it for multiple different kinds of services. So what we do is also, instead of just using single cells, I think one of the most important thing that we try to create is also clusters, which means we group cells dependent on the use case. So if you would have an area for a building, a farm, a mining area, an industrial area, an airport, that whole region we sort of cluster into one specific group of cells, and we compress them into a single ID. So everything within that area is connected to a master identity, which makes it much easier to manipulate data within a specific region. What you see here in this image on the right is actually a building. So what we do, it's all done automatically when reading in your AutoCAD file or IDF file or any type of data that you have regarding the venue, is we automatically cluster the complete building, but also the inside. So you'll see different clusters for shops, for walkable areas, for any type of different area. And you can start programming these locations specifically on their need, search for products, search for services, facilities, and all these kind of things. Next to that, I think what's important is that we also use the cells to create our own routing algorithm. So what we've done, and we're unique in that sense, we've sort of used the game engine thinking, where you move from one pixel to the other pixel, and we've implemented it in our own routing algorithm. So what we do is we look at the cells and calculate with our algorithms the most efficient route from one place to the other. And our technology is mainly also of a unique value in complex areas and the less traditional areas where there's a less defined road network. So you can see that it's from a venue perspective. You can see it from outside urban areas, but also, like I said, airports, industrial areas, all these locations where normal street navigation is much more complex. We can actually create navigation in all these areas using our cell structure. And what's key to this is that also, if you look at the indoor, if you look at warehousing, distribution centers, our algorithm can be adapted for any type of vehicle. If it's just cars or two-wheelers, but you can also change navigation for forklifts because they have a different turning circle, or for specific wheelchair navigation where you need more distance from walls, etc. All these things can be easily adapted. And key is as well that their routing is updated real time. So if some information on the cell is changed because it's unavailable, either to a roadblock or through an emergency or a fire alarm, routing is immediately changed and adapted. So you always have a routing that's continuously up to date. Next to that, the cell structure in that sense also, like I said, makes it much easier to structure our data and to search the data. So we've reused that to create our own geocoding system. Of course, current geocoders are very good with locating specific addresses, but a large part of the world still doesn't have a precise address, or addresses are more formed in sort of descriptive ways of defining locations. And what we try to do is use our cell data to add the context of locations where you can search for. So instead of just searching for an address, I'm looking for street address ABC with number XYZ, you can actually start searching for a location that is near a bakery or across a postal service or within 5 meters of a station. All these sort of semantics and spatial relationships that we have on our data sets in our cells can easily be added. And by using the cell structure, it's much easier for us to understand that data and the relationship between these locations. So related to this is, like I said, using our cells, using our grid, we create a way to create your own programmable locations, which means you can, like I said, with the geo IDs, with the cell address, with the cluster address, we create unique endpoints that you can continuously interact with and program. So if you want to have specific measurements for regions, let's say in the case of an event where you say, okay, if within this area we see that it's becoming too crowded because our camera sensors or say that there are more than 1,000 people in this region, we automatically block it and reroute people around that area. Or if there's an emergency, if we see that there's a a medical emergency in that area, we can block certain regions so people are redirected. Or for deliveries, if we see that the delivery guy is within a specific area of where he needs to have the package delivered, we can start initiating payments or transactional chats and all these kind of things. So it's all about creating an infrastructure that makes it much more efficient to start programming to locations, to start adding scenarios, all predefined scenarios that become actionable once certain events are triggered. And that's why we see our grid structure becoming an essential part, because you have the uniformity of these locations and the grid continuously communicating with the cells. That makes it much easier to program these things. But besides having a good infrastructure, I think for us, a key aspect of what we don't want to do is also making it very easy for anyone, for a business, for a community, for whoever needs it, to create your own private map. You can see it as logging into AWS or Google Cloud and setting up your own environment. But within our studio applications, you log in and create your custom map on the fly. On that map, of course, general public data that we source from OpenStreetMaps or Here Maps or any other map provider that you would like is always available, but you can actually start adding your own point of interest data for your own data sets that you have, or actually have your community, your workforce, your consumers start adding data. This can be data regarding point of interest, it can be routing data, it can be any type of data that you want. But key is that all these data points are added real time, so they're immediately searchable and visible for everyone that has access to your map. And there you have complete access management over who gets to see this for. If you want to share specific data regarding your venue with a supplier, you can give them access for a day or for a week, and they have all the information that they will need. Same goes for your consumers or your drivers. They always see the data that they have access to. And most importantly is that all the data that is added to your map belongs to you. We believe that data ownership is a critical part of where the mapping data is going to. So UNL in itself, we don't get to see the data, or no one else for that matter, unless you define otherwise. And that's why by adding this data to your map, you actually create your own data value that you can then share within your ecosystem and your suppliers. So key is that creating your own private map becomes a very easy thing to do, and maintaining it by connecting your APIs, by connecting your sensors, by connecting the applications that you already have with your users, all of that automatically to update your mapping information. So key to what's UNL, we see ourselves as a next generation location platform where people have the ability to update mapping real time, where they own the data that they actually add to it instead of giving it to another company, and having the ability to create your own tools, data sets, everything on top of it as easy as possible, and share it within your community or within your business. Okay, that was a presentation from our side. I'd love to hear any questions or anything that you have to add to our story. Thank you so much.
Thank you, Pascal. So now we've come to the end of the GeoMarketplace event. We have some time for Q&A. So if anyone in the audience, you have any questions to ask the speakers, feel free to leave the questions in the Q&A chat box so we can take a look at the questions. So in the meantime, I think for the speakers, just in case the audience would like to connect with you directly, perhaps you can leave your email addresses in the chat box, and the speakers can also reach out to you directly if they want to ask you any questions. Okay, if there are no other questions, then we will end off the session today. So thank you all speakers for your interesting presentation. We hope that everyone learned something insightful. So we have more webinars coming up next over the next couple of days. Do feel free to tune in to any of our sessions. I'll be leaving the registration link in the chat box. So please click on it to find out more about our festival and also to register. Thank you everyone and hope you have a good week ahead. Thank you speakers.
Thank you. Thank you, Jason.
Thank you, Rishan.
Your own